Hello, my name is Caela Morrell, and this is our cloud deployment project. In this video, I'll walk you through the cloud architecture and AWS services we use to build our fictional project called Clinic, a cloud-based healthcare platform. I'll also share some screenshots of the key configuration steps and reflect on the lessons and challenges we encountered during this process. First, I will discuss the business overview. It is a digital solution designed for clinics and healthcare professionals to manage patient data, appointments, and administrative tasks all in one place. It offers services like online appointment booking, medical record storage, doctor dashboards, and patient reminders, all hosted in the AWS cloud for better scalability, reliability, and security. Here's a quick walkthrough of the cloud architecture we built for Clinic using AWS. We start with the load balancer, which distributes incoming traffic to a target group managed by an auto-scaling group. This setup ensures that Clinic scales automatically based on demand. All EC2 instances are monitored using CloudWatch, with dashboards for performance metrics and alarm for alerts. Inside the EC2 block, we have a Clinic web server running on Amazon Linux. It serves the web application using Apache HTTPD. The instance is secured by security groups, allowing HTTP and SSH, and it uses an IAM lab role for safe access to AWS services. Finally, the WebDB MySQL database stores and retrieves all patient and customer data securely from the back end. This architecture is simple, scalable, and secure, perfect for a healthcare web app like Clinic.
Hi everyone, it's Priya taking over here from now. So in task 3, you're supposed to take the EC2 web instance and deploy it to a web server. In order to do this, I connect the EC2 instance to the SSH protocol and open up the Amazon Linux 2023. And from there, we start command by sudo su, which allows you to execute commands using the security rules. After that, we also try to install the HTTPD by using yum install HTTPD and check its status and see if it's updated. And HTTPD, it's an APAC web server which has HTTPS package, and then this allows you the web server to be deployed. And from there, we can also check the system CTL status update, which tells you to utilize the control system and gives you the status of the HTTPD. We can also make a directory using mkdir, and the directory name is temp for now. But in this task, we did not utilize any code whisperer. Instead, we went with like an HTML template of a website and tried to deploy it in a way that it looks like an actual website for our own service. So this HTTP template, we got it from we used like a CSS template maker, and then we chained the directory to the wget and used the link of the HTTP template, unzipping the complex files of the template. Then we can finally see that we can move this command and rename all these file names and make it to enable the HTTPD system CTL. And after that, I would like to show you how our website looks like now. This is the deployed website that you could see. It shows all the company name and all the informations that any customer would like to see and what all solutions that we do. You can also click on each button and it will show you that it's all clickable and it'll show you further informations. And we were successful at doing that. Next up in task 4, basically we choose the instance and make sure the instance setting we have enabled the termination protection, which I've already done that, and I've already changed the instance type in the settings, where I changed it to t2.small, which is more stronger than t3.micro. This one has more powerful, has more memory and more CPU storage. Therefore, we can also see that when you choose a web instance, it already gives you a graph of all these CPU utilization, and this is all in average, the network in, out, in bytes, and CPU credit storage. This all is in average. You can also see the system log from here. Yep. So you can see that it's all fully working, and you could also get the instance screenshot to monitor your instance and also connect it to the Amazon Linux whenever you want to see it. Now I also want to show you the dashboard we have created. This is the dashboard that we have created in order to just check the CPU utilization, the network in versus out, and also check the credit usage. You can also view this in CloudWatch using other metrics in EC2, but I think so far these are the most important ones to watch out for. In task 6, we head to the Aurora and RDS service. Here we created a database name as WebDB. Here's the configuration of the database, which shows you the endpoint and the port for 3306, which is the HTTP, and it's available in US East Zone 1A. There's also a different security group that I had to create especially to attach it to this database server so that you can deploy it on a web server. Now I would like head to the Linux file, going back to the EC2 service is connected to SSH port of each nano index HTML that we have created for the heading of the customer details, and if there is any invalid contact or if there is more process and editing of the contacts, so that we can create a database of the list of our customers. So all together we have created index, remove contacts, process, edit contacts, taking the public IP address, and then do the customer details, and you can also edit and remove these contacts. You can also update the contacts however you like it and play around with it as much as you want.
Next part, I'm going to talk about personal reflection. Working on this project has taught us a lot about how cloud systems are structured in real life. Here are some key takeaways. First, the hands-on VPC setup helped us understand how different components like subnet, NATs, gateways connected securely. Then integrating EC2 and RDS showed us how to build a full-stack application on the cloud. And lastly, using CloudWatch gave us visibility into system performance and helped with optimization. And lastly, I'm going to talk about challenges and solutions. Networking was the hardest part. At first, we couldn't connect my RDS instance from an EC2. After debugging, we realized that we needed to update the DB security group and subnet group. It was also difficult to connect RDS database to EC2 using Linux. We ensured two MySQL securities by configuring libraries. Then wrote HTML scripts to construct tables such as where you added contacts, edit contacts, or remove customer details. We used Nano, which is a simple, easy-to-use text editor for Linux and other Unix-like systems. It's a command line editor, meaning you use it directly in your terminal. Another issue was attaching the EBS volume. We had to learn how to format and mount it manually in Linux. And lastly, the auto-scaling and load balancer setup was also tricky, but creating an AMI and using launch templates made it manageable after going through AWS documentation. Thank you for watching our presentation.